All right, just look at this. I mean, what you're seeing here is one of the most incredible and honestly kind of haunting shapes in the entire cosmos. It's this ghostly skeletal hand, and it's stretching across trillions of kilometers of space. It's an image that just fires up the imagination. But what is it really? A cosmic ghost? Or is it something way, way more powerful?
So that's the big question, right? That's the mystery we're going to unravel together. We're going to look right past that beautiful, eerie shape and dig into the violent, super energetic physics that actually created it. So let's get into it. What is this so-called hand of God?
Okay, so officially, this thing is known as MSH 15-52. It's this gigantic cloud of gas and particles about 17,000 light-years away from us over in the constellation Circinus. Now, astronomers call it a composite supernova remnant. What does that even mean? Let's break it down.
So at its core, what we're looking at is the aftermath of a star that just blew itself to bits. That's the supernova remnant part. And the word composite, that just means it's made of a couple key parts. You've got the outer shell from the explosion itself, and then this inner nebula that's being powered by whatever was left behind. And that little leftover, well, that's the real star of our show.
Now, here's the part that's kind of hard to wrap your head around. This entire massive structure, this hand that's bigger than our solar system, is being lit up and powered by something that is ridiculously small and dense. A tiny, ferocious little engine right at its heart.
That engine is a PULSAR, and its name is PSR B1509-58. You can think of it as the super-crushed core of the star that exploded. It's a neutron star, and it's so dense that a single teaspoon of it would weigh billions of tons here on Earth. And it's sitting right there, at the bright palm of the hand, just blasting out this incredible wind of particles that shapes the whole nebula.
And get this, in cosmic terms, this thing is a baby. It's only about 1,600 years old. That makes it one of the youngest and most energetic pulsars we've ever found. It gives us this amazing chance to study one right in its prime. And the reason it's so energetic is its insane speed. This pulsar is spinning around 7 times every single second. Seriously, try to picture that. An object more massive than our sun, crushed down to the size of a city, rotating as fast as a kitchen blender. All that rotational energy is what's powering everything we see.
And the amount of power it's kicking out is it's staggering. It has what's called a spin-down luminosity. That's the energy it's shedding as it slowly spins down over millennia. And that energy is about 100,000 times the total energy our own sun produces. It is an almost unimaginable gusher of power being pumped into the gas around it, creating the hand of God.
Okay, so we've got this powerful pulsar creating this hand shape. Simple enough, right? Well, not quite. This is where the story gets a really fascinating twist. It turns out the hand of God has a secret, a ghostly twin. Because when we look at this object with different kinds of eyes, with telescopes that see different kinds of light, the picture changes completely.
First up, let's look in X-rays, using data from the amazing Chandra X-ray Observatory. This is the classic image, the one you've probably seen. You can clearly make out the bright, defined fingers and that central palm. It's a pretty compact, well-defined shape, and it's tracing the highest energy particles being flung off the pulsar. But now look at what happens when we observe the same spot with gamma-ray telescopes, like the H.E.S.S array. The picture just totally changes. The hand becomes much, much bigger, more spread out, more elliptical. It's like a ghostly twin of the X-ray nebula. So what on earth is going on? Why are we seeing 2 different shapes in 2 different kinds of light?
You can really see the difference here. The X-ray hand is compact and bright. The gamma-ray version is bigger, kind of fuzzy, and stretched out. This is because they're being created by electrons at different energy levels through 2 totally different physical processes. The key thing to realize is we're not seeing the exact same cloud of particles, and for a long time, that discrepancy was a huge puzzle for astronomers.
So how do you solve a puzzle like that? How can it have 2 different shapes? Well, the latest research suggests something really cool. We're not just looking at one nebula, we're looking at 2. We're seeing a ghost of the nebula's past, a relic left over from the original explosion.
Yeah, this is the million-dollar question scientists were wrestling with. Why does that gamma-ray glow extend so much farther out than those bright little X-ray fingers? The answer, it turns out, takes us all the way back to the moment that star exploded.
The leading theory, and it's a brilliant one, is that we're seeing 2 structures, one laid on top of the other. The bright X-ray hand is the modern nebula, being powered by particles the pulsar is shooting out right now. But that larger gamma-ray halo? That's an older cloud of particles, a relic that's been pushed outwards and re-energized by a shockwave from the supernova itself. Scientists have a name for this, a relic pulsar wind nebula. See, when the supernova blast wave expands out, it actually creates a reverse shockwave that travels back toward the center, kind of like an echo from a huge explosion. This shockwave comes roaring back and just slams into that older, first-generation cloud of particles from the pulsar, pushing them aside and lighting them up in gamma rays. We're literally seeing the nebula at two different stages of its life at the exact same time.
So you see, this is way more than just a pretty picture in space. Understanding these two different views of the hand of God gives us this unique window into some of the most extreme physics in the universe. It's a perfect natural laboratory.
So let's quickly get into the how. How are these two different kinds of light even made? Well, the X-rays come from something called synchrotron radiation. That's where super high-energy electrons spiral around magnetic field lines and shed their energy as X-rays. But the gamma rays are totally different. They're made by a process called inverse Compton scattering. It's like cosmic billiards. A fast-moving electron slams into a low-energy photon, like a bit of starlight, and transfers a ton of its energy, boosting that photon all the way up to gamma-ray levels. And that can happen over a much bigger area, which explains that ghostly extended shape.
And what's just nuts is how incredibly good this pulsar is at making gamma rays. PSR B1509-58 converts about 0.6% of its total energy output into very high-energy gamma rays. Now, that might not sound like a lot, but it's nearly 40 times more efficient than the famous Crab pulsar. It's one of the most effective cosmic particle accelerators we've ever found, and it really challenges our models for how these tiny engines can pump so much power into their neighborhood.
So, when we look at MSH 15-52, we're really seeing more than just a cool shape. It's a dynamic cosmic laboratory. By studying the two different nebulae, the relic and the new one, we can learn how particles get accelerated to insane energies, how magnetic fields work around pulsars, and how the chaotic aftermath of a supernova evolves over thousands of years.
And all of this leaves us with one last really fascinating question. The hand of God was hiding a ghostly twin this whole time, one that we could only see when we finally looked with gamma-ray eyes. And it just makes you wonder, what other cosmic secrets are out there, hiding in plain sight, just waiting for us to look in a new way, with the right kind of light?